Hello everyone, my name is Jesus Olivares. I am the project manager for Da Vinci team number 4 from El Paso, Texas. So in this video we're going to be going over the engineering and the science process, a really important element of this project being InSPIRESS. So what's InSPIRESS? So this project dedicates to the designing and planning of the mission to a specific destination within our solar system. In this case it's Enceladus. So the purpose of the mission is discovering more about the nature of this remote place and engaging with real material that engineers use on a daily basis. So for our case, we're collaborating with engineers at the University of Alabama at Huntsville for earning more knowledge and preparing for this mission the proper way. And one fundamental element for this mission is the engineering design process. This consists of 6 basic steps, being defining the problem, gathering pertinent information, generating multiple solutions, analyzing and selecting a solution, testing and implementing a solution, and finally communicating results and improving the solution. So this process really involved within our project, since we had to progressively improve and get better with it. So today we're going to be going over how our science objectives, our payloads, and our team identity change as we use this engineering design process.
When starting InSPIRESS, we had to come up with a science objective. And there were many options that we had to choose from. And one of the 3 main options that we knew we were interested in was geologic activity, surface analysis, and tiger stripes composition. This was obviously one of the main problems since we had to choose something. However, we also came up with a solution, and one of my teammates, Natalia Figueroa, will say more about it.
We solved this problem with UAH decision matrix. We used foams like interest of team, mission enhancement, and public understanding. Our team used a decision matrix to establish a verdict, which would essentially define the entire project. It helped us evaluate the best option according to the team.
Our team decided on choosing the science objective tiger stripes composition. Tiger stripes are 4 linear depressions located in the south pole of Enceladus. These depressions contain glaciers that shoot out elements which go into Saturn's rings. We want to find out exactly what comes out of these tiger stripes and if they contain life-supporting elements. Now we should move on to the payloads.
So when it comes to the payloads, the engineering design process is really important. So as we mentioned before, we had 2 different concepts for the mission. One was created by Team A, and other one was created by Team B. Team A's product was E.D.E.N, an acronym for Enceladus Valiant Explorer. The second concept created by Team B was Siegfried and Roy. So the 2 concepts had a different design, a different nature, and a different intention when it came to the mission. E.D.E.N tended to go straight into the tiger stripes, and Siegfried and Roy also go into the tiger stripes but also staying within the top portion. So for addressing this problem of creating a payload that will fulfill our mission, we have these 2 alternatives, the 2 solutions for this. So after reviewing it with a concept selection trait study provided by UAH, including our exclusive figures of merit, we decided that Siegfried and Roy was the most ideal payload for fulfilling a mission. Eventually, after reviewing the 2 payloads, we concluded that 2 had really good features. Even though Siegfried and Roy was a superior model, we incorporated the best details from E.D.E.N into Siegfried and Roy, and eventually we reached a compromise, scrap and acorn. So this model was a really preliminary one. It was not really developed, but progressively we wanted to refine this idea. As we communicated the results to other professionals to get their feedback over this payload, we obtained more and more details for incorporating into our payloads, different instruments, a different distribution, getting the best out of the 2 original payloads, and drawing upon knowledge from other individuals. Eventually, we reached the final design, scrat and acorn, that you may see in the image.
Hello, I'm Derek Boltron, ACE member. I'll be talking about our process for the logo. So originally we all decided to go kind of like an unorthodox method. We decided to everybody come up with the logo design, and then eventually we would bring them all together and decide which one we liked best. But this came to a problem because no one could decide which one looked best or what we liked from each certain design. So we ended up finding middle ground with Ms. Reyes, who is our art teacher for the school, and she helped us decide what she likes from each design, and she put it all together, and she basically helped us find the logo we have now.